So welcome everybody. Like Pete said earlier, we're kind of excited seeing so many people in the room ready to listen to all this great stuff we're going to show around sequencers and synthesizers and all sorts of geeky fun up here. My name is Jason Olson. I'm a senior program manager on our media platform team in the operating system group.
And I'm Pete Brown. I'm also somehow a program manager, but I don't actually own any products. So.
Oh, that's funny how that works. So what are we going to do today? Well, there's a couple things that we're going to talk about. Why music creation apps? Why should you care about this? Why would you want to actually develop your own apps?
And then after that, we're going to talk a little bit about MIDI. And I saw a couple of people that were coming in here who were asking me questions about MIDI. Who's here to learn more about MIDI? Sweet.
Nice.
Okay.
It's
nice.
The right room to be in. And then finally, we'll talk about low latency audio and what you really need to do for Windows Store apps, Windows Phone apps, all that kind of stuff to really achieve true low latency audio on our platform.
Yeah, and just one more time, just to refresh my mind, how many people in here have been building audio apps? And how many people are using audio apps, like creative audio apps? Sweet. So
nice.
That's a pretty good turnout. A lot of folks, a lot of interest in that here.
So one of the things is this is going to be kind of a hybrid code talk. We're going to show some C#. We're going to show some C++. We're going to show WinRT, COM. It's going to be all sorts of GUI fun that we're going to talk about today.
Great.
So one of the things that we're actually going to talk to is why build a creative music audio app? Why should you care about this? Well, as a musician, inspiration comes anywhere at any time. You know, the muse is very fickle sometimes. The one time you sit down at your desk to create music is the one time you have no inspiration to create music. So in the role of phones and tablets and everything, if I have a great music idea while I'm at the airport or while I'm at my kid's soccer game, I can use these apps to actually right there start capturing my ideas so then I can really flush them out later.
Yeah, or if you just want to make random noise on the train to have everybody kind of confused, you can do that as well.
Right, exactly. All the funny bleeps and bloops and stuff that you like doing.
And it's kind of interesting because if you look at some of the different app stores, the creative music and creative audio apps are some of the most popular apps in those stores. They're also the ones that command some of the highest premiums price-wise. So you might spend $5 on a game, but you might spend $15 or $20 on creative music apps, and they're also more likely to be, much stickier with the user. They're something that they're going to turn to and become a critical part of the things that they do from day to day. So there's a lot of appeal to being able to have creative audio, and also, creative video stuff as well. Mm-hmm. We're really targeting audio here, though. Have those apps in the store because people are going to use them, and they're going to be engaged in them, and they're going to be using them constantly, and they're going to be very excited about that.
So one of the things that I'm really excited about as a musician is that there's a whole industry dedicated to creating these great devices that are out there that you can create music with. And one of the other things I'm also excited about as a Microsoft employee is now we're kind of putting our money where our mouth is. Like I mentioned earlier, I work on the media platform team. The name of my team is actually Media Creation and Editing. Yep. So now in the operating system group, we actually have a team dedicated to these scenarios around media creation and editing that we really want to focus on how to make really good creative music apps on our platform.
Right, and this is something that, if you look at a lot of the other talks, we focused a lot on the consumptive media. We've always had some good support, especially on the desktop for creative media apps, but on Windows Store apps themselves, we focused more on the consumptive scenarios first. Now we're really starting to look more to how you can be creative, using a new platform, how you can get really creative apps in the store. And just like Jason was saying, the fact that we have teams now dedicated to these scenarios is a huge step and really important. It shows investment on our side. It also shows we're working with a lot of partners to get feedback on these types of apps to be able to enable different devices to connect to Windows, and we're trying to get their feedback in and make sure that the APIs that we work on, the scenarios that we work on are all the right things to enable these types of apps.
Yeah, and today we're actually going to show even some new features coming in Windows 8.1 and Windows Phone 8.1 that enables some of these apps to really be created more powerfully. Like some of this stuff, Pete, like I have some of these devices at home that we're showing here. It would be great if I could actually hook that up to a Windows Store app and actually use it to play stuff in the Windows Store app.
Right. So we have some partners we've been working with, one of which is ImageLine. So anybody here ever use FL Studio? Right, so I've been working very closely with them for a while, and we've got a really great app in the store called FL Studio Groove. So how many people here haven't seen FL Studio Groove? Okay, you guys weren't paying attention earlier, I don't think. All right, good. So let me quickly show that. I think it would be good to show that.
Good. Let's show this in action. Yeah, 6.
All right, so let me get over here. I'm going to go to my desktop. Now, this isn't a touchscreen PC. Normally, this is something that you would play on a Surface or something like that, but I'm going to just mess around a little bit with the mouse here. But because I am not a musician, I'm going to use one of the canned tunes that are in here. And let's see if we can have audio out working pretty well. So this is an app where we can see keyboard. You can do sequencing on this. It has multiple channels of audio. It does quite a bit for enabling these really kind of creative. I don't want to say noodling scenarios, but they're really the sitting down on the train or sitting down in the airplane and trying to work through some themes, and then being able to take that and do something else with it. Right?
So this Novation you have, it's kind of cool. I mean, I could imagine that being in my backpack, so I could have that on the train.
Well, don't imagine it too much, because this is mine. I don't want you taking that. Thank you.
Okay. I promise I won't take it until after you're back.
So this is a very basic little keyboard controller. It's got tiny little keys and stuff on it, but it's very nice because I can travel with it whenever I want. So this is something that I do bring with me. I have a gear bag that I check. I used to bring it through security at the airport, but I found out you do not want to bring a bag of gear through security unless you want the special search at the airport. So I do have these and some other synthesizers.
So do you know that from personal experience?
I'm not saying. I plead the fifth on this.
Okay.
All right.
So it would be really cool. I want to see, can we hook that up to this app? Would that actually work?
Why, what a great idea. Let's see if we can do
goodness.
that. Not expected at all. So that was FL Studio Groove. That's a Windows Store app. And I'm just going to plug in real time and hopefully not have anything strange happen.
It's okay. It's your demo. If it fails, I'll blame it on you.
Okay, we had the USB sound, so that's cool. Now let me go back into FL Studio Groove. Okay. And pull out this chill out loop here. Now remember, we are looking at the Windows Store app. Now what happened, this is the same app, but it lit up with a couple of new options at the top. So right now, it's we have the ability to pull in different USB MIDI devices. So I've hooked this up now to the MIDI device right here. And if that all
Right. And you said, so this is a Windows Store app?
Yeah, so this is a Windows Store app. This is not something that has worked before. We don't have any ways of enabling this. But now we've worked with ImageLine to make this possible here.
Because goodness knows, I've wanted to do this kind of thing since we released Windows Store apps.
Right.
So the thing is, let's go through how this works. How did FL Studio actually make this happen?
So who here is not familiar with MIDI? Everybody knows MIDI. Sweet. This is the only room I've ever been in, short of being at NAMM or something, where everybody knew what MIDI was. How many people here are younger than MIDI?
I'm pretty sure I am, Pete. Yeah.
Yeah. Okay. So I was 12 when MIDI came out. If we want to,
I wasn't born yet.
Yeah. So MIDI is a musical instrument digital interface. It is originally a serial protocol. How many people here have ever owned a modem? All right, a fair number of people. How many here have ever owned a modem that was slower than 56K?
Nice.
All right, how many of you are doing the 1200 ones? This is an old room. This is an old room. 7K, there we go. How many people here had to carry the bits from one location to another, right? All right. So MIDI is a serial protocol, right? It's originally over these 5-wire cables. I've got a bunch of them hanging around. They're the types of things that trip you when you're walking around on stage and other stuff. But this is something that came out around 82, I think it was, 81, got standardized. And it became the standard way for synthesizers to talk to each other. And it's a very simple protocol. It just sends packets of serial information across, 5 volts, all that kind of wonderful stuff there.
And it's still used today a lot.
Yeah, so that's
everywhere.
a crazy thing, is as many times as different standards groups have tried to revamp MIDI, it's still the 31.25 or whatever it is kilohertz serial protocol. And the big change that has come about somewhat recently is the addition of USB MIDI, right? So USB MIDI is what enables you to connect a USB class compliant or sometimes a required driver MIDI device to pretty much anything that has a USB port. So for example, the Novation stuff I have here, the Analog 4 that I have here, they connect to the PC using USB, okay? And that USB then, that signal has all of the MIDI information on top of that.
Now, so not FedEx, it's just a protocol.
Yeah, it's just a protocol over that. Now, we've always had the ability to interact with MIDI on the desktop, right? But we haven't had the ability to interact with MIDI on Windows Store apps.
Correct, so. As much as I have always wanted to. So announcing today, we do have a new WinRT MIDI API that is available. It's a preview available, and we are also making it a go-live license. So starting today, you'll be able to download that as a NuGet package and develop apps that you can release to the store that'll work on Windows 8.1. Yeah, exactly. Thank you.
Great. So the really cool thing about that, so it's a preview, right?
Yeah.
That's okay. So we want feedback from you because it is a preview, okay? The other thing is we release it on NuGet. I mean, how cool is that to release a Windows API on NuGet? I think that's a pretty cool idea.
Yeah, exactly.
Right.
So yes, we definitely want to hear your feedback and it sounds like a lot of people are actually going to want to go use this kind of stuff.
Yeah.
So do you guys want to see what the API looks like and how you'd use it? Yes, everyone's saying yes. So I think we can probably...
Did anybody say no?
I don't think so.
Okay, because we're just going to have that person stoned in the back of the room.
Exactly. What about Windows Phone? So we're looking at options on what to do on Windows Phone in the future. This doesn't work, but we're looking into things like RTP MIDI and other things that we can do to support MIDI, like over the air using other communication protocols.
Right. So,
yes,
so that's
RT.
a really good point.
Yes.
So right now, this protocol is USB MIDI, but
Yes.
we're looking for feedback on, what are the other protocols that you want? Like, is RTP MIDI, is MIDI over Wi-Fi and stuff like that? Are those important scenarios to you? If they are, and you have use cases where you really want to do those, then please, send your feedback back to us, after the session, or, tweet them to us or anything like that, because we want real feedback from real people developing apps. Okay?
Yeah, absolutely.
The other thing that's interesting is this is the WinRT MIDI API. So right now, it'll work on ARM, it'll work on x86, it'll work on 64-bit. What about the desktop?
So that's a good question. So at release, we're planning on it working on desktop. There's a couple issues we're working through right now, so these bits in preview won't work on the desktop, but the long-term plan for Windows is that this will be the MIDI API that you can use on Windows and other OSs going forward.
Yeah, so we're encouraging people that, once we have this out and available for the desktop, when you're targeting these new versions of Windows, please, feel free to try to migrate to this API to get advantage of the work that we're doing to lower things like jitter and work with latency, and also to do a lot of the innovation on top of this stack, right?
Yeah, and the great part is this is a new stack from bottom to top, so it's not like we just took a WinRT wrapper around our existing Win32 APIs. This is brand new, so we can make sure it's high performant and is meeting all the needs for these apps.
Okay, cool. So you guys said you wanted to see a demo of this, so let me switch over. Here we go, cool. All right. Now, because I'm not going to rely on networking here up on the stage, I have the package locally, but I'll still use NuGet to get there. But that should be in the store now, or pretty soon to now?
Yeah, hopefully. We were kind of, it was on staging, getting ready to go. So if it's not up there as of this second, you can follow our Twitter streams, and we'll make it actually available, and we'll tell everybody when it's up there ready to go.
Right. And like we said, if you find any bugs at all, just please let us know. It's a preview API, and it's really, this is a real preview. This isn't the beta where it's actually all done and we just want to give people early access. This is a preview where we really do want to get feedback
Absolutely,
on this.
absolutely.
Okay. So let me start this up. I'm going to do a XAML C# app to demonstrate this. I'll just hit OK in here. Now, one of the first things that we need to be aware of, because this is a preview, is we need to target a specific architecture, right? As a C++ developer, you have to do that anyway.
Yeah.
As a C# developer, we're not going to use the any CPU version of this. We need to specifically change this to the architecture of the machine that you are targeting. So I'm running 64-bit Windows. I need to go and change the build configuration here. So instead of seeing any CPU, I'm going to target x64. That's just an artifact of this being a preview. It's an issue that we know about, and I know, shout out to Mike Chemistruck and stuff, the folks who are really working on this.
Yeah, absolutely. We're going to work through that.
Okay. So now I have the C# app. There's nothing else in here. I am going to add the NuGet package. So, manage NuGet packages. And like I said, I don't have Wi-Fi right now, so I was going to check to see if the package was out there, but I'll just use this local one. So we have the Windows Runtime API for MIDI preview. Everybody sees that? I'm going to install that. I accept the license, because I don't think we've ever put anything out that didn't have a click-through license of some sort or another.
Yeah, of course.
All right. Close that. And now you'll see under references, you'll see under the packages I installed here, I should have the Windows preview.devices.midi package. Now, how many people here have done Bluetooth programming or any other devices? Okay. Are you familiar with the model for acquiring a device under Bluetooth or other stuff? Right. So you use the device information collections and
and loop through and find all async and look for the devices that are there.
Right. So we're following the same model. So this should be very familiar to anybody who has been using any of those other types of device APIs. But the first thing I want to do is, because I'm not that much of a masochist, by the way, see, the designer doesn't work on x64, so keep that in mind. Before you change the target architecture, if you are doing some XAML UI for this instead of DirectX or something, you're going to want to do all that before you go and set the architecture to x64 on your machine. So a little tip there. Again, just a preview thing, right? I'm not going to deal with the designer anyway.
So it seems like the first thing that we want to do is actually enumerate the devices.
Yeah, but I need to get some UI. So,
you should probably do some UI first.
So I want to put that in there. So let me get this main page. Samuel, let me delete this stuff. I do have a couple of drag and drop things that are sort of ancillary to the rest of the discussion here. So if I go up.
Now, so granted, the thing is, this is the UI code. You'll actually see the code to make a decent looking UI is longer than the code to actually work with MIDI.
Funny.
So.
All right. Yeah, it's, there is more XAML on this project than C# code. So then the second thing I want to do, just so this will compile, is I want to put in the event handlers that I had inside, that were referenced inside XAML. Now let me, if I didn't do anything wrong, let's see if I run this. Oh, hey. Oh, OK. I have an extra grid tag, thank you. Oh, at the top? Here we go. Oh, I see. Thank you so much. Usually you guys just let me suffer through it. You know what's wrong, and you're like, all right, so now let me try it. And that is why I didn't type this stuff by hand, because there would be a lot of that going on. Okay, so this is the UI. So this is just XAML stuff. A lot of C++ developers will want to get maximum performance. We'll talk about that in a bit using DirectX. But we actually found that just using straight XAML, I mean, you found it in some of your examples?
Yeah.
Pretty fast, pretty slow?
Yeah, absolutely.
Right.
Yeah. It meets my needs.
Yeah.
As we'll see. Oh, jeez.
All right, we're not going there. All right. So now I've got the UI in there. I want to do, you said I need to do device
let's get the
enumeration.
devices. I mean, you had that input and output devices list.
Yep.
What do we need to do to actually find the MIDI devices that are attached to this machine?
All right, so the first thing I'm going to do is using Windows preview .devices.midi. Okay, so I've got that in there. And then I'm going to enumerate. So I'll create a new function in here, and I'll call this, let's see, private void initialize MIDI. And you guys didn't realize that you're going to spend 15 minutes watching me type badly, right? Okay. So
everybody's thinking how much better they can type than you.
Of course they are.
Yeah.
I need one of those, what do we call that, the geometry keyboard? Do you remember? I need one of those on here. No. So there was an April Fool's joke where somebody had announced swipe for physical keyboards. Did you guys see that? I thought that was pretty funny. All right. So I'm going to initialize MIDI. I'm going to enumerate devices. So there's a thing called a device information collection. I'll need to have a couple of those because I've got those two lists on the screen.
You want the input and output.
Yeah, so I want some collections of those devices. So I'll say device information collection, and I'm going to want to resolve that. Yes, I know there's a hotkey for that. So device information collection, I'll call this, let's see, input devices, and then I'll do the same thing for output devices. Okay, and these are MIDI devices, right? So everybody knows how MIDI works. You need to have something coming one way, something going another. Yeah. It's not bidirectional, communication on those, although they do that over USB. But traditionally, the devices were always one thing, one port going in, one port going out, and the through was also, another out. All right. So let me put initialize MIDI in here so I don't forget to do that. So I'm going to get the devices. So I'm going to say, let's see, input devices equals device information dot find all async. And for anybody who's familiar with how the API works, we need to pass it something.
Yeah, we need to pass it a device selector, essentially. So what kind of devices are we looking for here?
So in this case, I'm looking for input devices. So if I look at the MIDI in port, there is, MIDI, is that right? There we go. Get device selector. Slight heart attack moment when I didn't see it there the first time. So I'm going to call the async method, which you see it's giving me a squiggly because I don't have async here, to pass in the descriptor that tells the operating system to give me all of the devices that meet this is it class or is it like a descriptor?
Just think about it as a selector, yeah.
Okay.
Think
So-
about it, you could even think about it as some special GUID that tells the system, hey, here's the devices I'm looking for.
Okay. So that gets me the input devices, and then I can do the same thing for output devices here. Output devices, find all async. Instead of MIDI import, I pass MIDI output to get that device selector. Now that's all I need to do to get back a collection of all the MIDI devices on the system. Now for ARM devices, those are class compliant MIDI devices. That also works on x86 and 64. But on Windows, big Windows on x86 and 64, we can get not just the class compliant stuff, but all the other ones that are just recognized by the system as being MIDI devices. So that's really cool. Again, if you're thinking about how to target ARM, make sure it's a class-compliant driver, so you don't need to actually install a driver on there. Okay? So I've got those. Now, the next thing I want to do is I want to populate the UI with that information. So I'm going to say input ports dot items source, and I have no idea why that didn't come up in IntelliSense, equals input devices. Oh, thank you again. There we go. All right. You should be up here on stage with me because you've been a huge help. Thank you. All right, output ports, item sources, output devices, and probably just I didn't compile. Let me make sure that's working.
Lowercase o, man.
Ah, jeez. Thank you. This is why you have to have two people on stage.
This is why you don't write JavaScript code, right?
Yeah. Yeah, exactly. I don't like write JavaScript code because I suck at it in general anyway. So now we have the list of input ports and output ports. I only have one device connected to the system, and that is the Novation. The Novation gives us access to two different ports. I'm going to close this, and I'm going to now plug in I'm going to plug in a random cable off the stage here and hope it's the device I'm looking for. All right. So let me... You guys have seen, like, you have to turn the cable 3 times to get it in the right orientation. It's one of those... There we go. All right.
Well, did
we
you
have reverb on the sound? I think so. That's great. This is an audio talk. So, sorry, go ahead.
I was just going to say, USB cables are like Schrodinger, where you actually have to do something. Until you do, they're actually in both states at once.
Yes, yes, yes. We are geeks up here.
Yeah.
Geeks first, musicians for you second.
Yeah.
Okay. So up here, you now see we have the Electron Analog 4 input and output. So that was just a USB device I put in. There were no drivers required. This is just standard class compliant stuff. Now that I've got that, so the Analog 4 is a sequencer.
Yeah, so
right?
I would imagine, can we actually go ahead and send some MIDI messages over to that sequencer?
Yeah, because I've been talking for 10 minutes here and we haven't sent any MIDI messages
Right,
yet.
exactly. I'm kind of getting impatient over here, Pete.
Okay, so before I send the MIDI message, let me just quickly deal with the selection change, because we need to be able to pick up which input or output device that you're going to use there. So when the list box selection change happens, I want to initialize or open the new device. So the first thing I'm going to do is say if input, oh, do I not have that up there yet? I do not. All right. So I say MIDI import, input port, and then MIDI out port, output port. All right, and then I'm going to go down and check to see if it's null first. So if input port is not equal to null, then I'm going to close it. So I say input port dot dispose. Okay? And I just want to make sure that I clean up in case the port was already open. And then the next thing I'm going to do is get the input port that they selected. So the way that you need to do that, like what did I bind the list box to? It's not a collection of MIDI ports.
Right, it's the devices.
Right.
Yeah.
Okay, so the collection of devices that's there is not a hard relationship between the device and the MIDI input port. It's just here are all our devices, and now I need to initialize a MIDI port using one of those devices. So I'm going to say MIDI input port dot, I'll say input port, there we go. Maybe I could use that special swipe keyboard on here, I don't know. So input port equals, and it's going to be MIDI import dot get from ID. All right, and now we're going to pass it in the ID because when we get those devices back from from the operating system, really all we care about is there's a name and there's an
Yeah,
IP
it's really
and
the
some stuff.
metadata of the
Yeah.
device. Yeah.
So I'm going to say, let's see. Do one more thing. You can tell coding on the fly here. I'm going to say the device that I'm interested in, so var dev equals e dot added items 0 as device information. Okay. So that's going to get me just the first one because it's just a single select list box. And then I'm going to say device.id. So dev.id. And there we are. And I'm going to need to await this. And then I'm going to need to async this. Good. As what did Miguel say yesterday? That we're going to use asynchronous calls here because we're not animals, right? So that's what we'll do here. All right. So now that process alone of just getting that MIDI import, that's all we need to do to open the port. At that point, it's available to us.
Right.
I think at least for the preview, and it's something we're looking for feedback on, that port is now locked to the app, correct? Right. So that port is available just to this app. We're not sharing across apps at this point. If that's something that's important to you, having multiple apps that are sharing the same MIDI port, and there's some sort of synchronization between that to make sure you don't stomp on messages, we want that feedback out.
Yeah, that's another thing we absolutely want to hear if that's a requirement for folks. It is, yeah. Yeah, immediately I hear everyone in the audience being yes, yes, yes.
Yes. Well, you know how it is. We'll have to prioritize that versus other stuff. Like, is this more important to you than, something to do with the timestamps or something like that? So we'll see. All right.
Yes.
Everybody says yes.
Like,
yes.
Yes.
All right. So the next thing I'm going to do is I'm going to do the same thing for the output ports. All right. So output port, because I can't even copy and paste up here. All right. Output port. There we go. So we'll say, I had the same problem on your keyboard earlier, and I blamed it on your laptop.
Yeah, exactly. I'm
Apparently it's
realizing
not
you
your
blamed it
laptop.
on the wrong thing. It's
the-
PEBCAC. The problem exists between keyboard and chair.
I think so. Okay.
Well, stage at this point.
Yes. All right, so now I'm doing the same thing for the output ports. I'm initializing that. So all we have now is that we've enumerated the devices, we've populated the list box with the input and output devices, and then when you tap on one of those or click on one of those, it's going to make it the active device. Now, finally, because
we're not sending messages yet, Pete. How easy is it for me, now that I have that output port?
Yes.
How easy is it for me to send a message? Like, can I start the sequencer?
Yes, so I am going to start the sequencer. What a great idea. So I am going to be a bad programmer and not check for null or anything like that. I'm going to say MIDI, output port dot send message. Now we have two different ways of doing this, right? You as a C programmer might be really comfortable with just sending a buffer of data over.
Yeah, or I might still want to do the strongly typed stuff if I'm using C++ CX.
Right. But if you want to be able to format the messages and deal with that yourself, you can just send a buffer of data over. MIDI messages are just a couple of bytes of data. Or you can use the strongly typed classes that we have. So I'm going to say output port.send message, and I'm going to say MIDI start message. New MIDI start message. And that's all I need to do to be able to send a start message. And then same thing with the stop. I can say new MIDI stop message. Okay.
Seems pretty simple.
It does. All right. Now, hopefully I've done everything I need to do. And hopefully you would tell me if I didn't. All right, so for input port, I'm going to say MIDI in. We're not doing anything with that just yet. For output port, I'm going to say the analog 4, and then let me hit start sequencer here. Hey, there you go. And I hit stop.
It's working.
Okay. It's like a John Carpenter movie or something going on here, right? So,
I love that. I love that. All the applause for the effect of one line.
it was the reverb.
Yeah.
It was the reverb that did it, right?
It's like the old Microsoft talks, look, Ma, no code.
And yeah, you put enough delay and reverb on something, and like people will applaud regardless.
Yeah,
so.
exactly.
Okay.
You're just missing distortion.
So the other thing that we need to do, so now we're starting and stopping the sequencer. I think it might be really cool to make some other noise out of the sequencer, but just send some actual notes or something.
Yeah.
Over.
Could you receive something from that keyboard you have there?
We could. I think, let's split that in half.
Okay.
So I think if we split in half and send messages first, and then we do the second half, which is taking in messages and passing them through.
Go for it.
Okay, that's cool. So let's do that. So on the screen, I had a bunch of rectangles that you saw there. So for each one of those, I want to be able to send out a MIDI note. So I have a table here, and I don't want you to have to have to see me type that whole thing because we've seen my record on typing so far. So I have this initialized touchpad MIDI notes, and all it is I have just a simple array here that is going to send out, that is going to assign to each one of the touchpads that are on the screen there a different MIDI note. And they could be anything. We're going to see later on other cool stuff you could assign to touchpads. So I'm going to go back up here into my constructor, and I'm going to initialize those touchpad notes. And then the second thing I need to do is to handle the pointer released and pointer pressed. I have all of the different pads that are on the screen going to the same event handler. So I'll just put in, let's see, this is pointer pressed. And I am going to get from the screen the grid, row, and column that I'm in, and I'm going to map that to the array and then output the note from there. So let me do that. Where's my touchpad message?
It's a variable you haven't defined yet.
Oh, that's great. So let's see. Actually, I am going to go over to my other app here, which is my backup really quickly. Actually, I'll go to my backup of my backup because it wasn't in there either, and I'm going to pull that.
This is like the Julia Child demo.
It is.
And this pie is baked in 2 minutes.
I have 5 ovens over here. All right. So now that I've got that, I can then do the pointer press. I didn't do pointer released, so let me just quickly copy over that code. This is really great programming. You can see all the stuff that I could have reused here, and I'm doing it via Control-C and Control-V. And instead of sending a MIDI on message on release, I'm going to send a MIDI off message. How many people here know the different ways of sending a MIDI off? Are there 3 ways? Are there 2 ways? Are there 1 ways? I'm calling all you MIDI programmers out on that because I don't think you really knew. So you can send the MIDI off a couple of different ways. One is you can send a MIDI off message. And then because, I don't know why, because you can also send a MIDI off, MIDI on. I'm sorry?
Because of running status.
That's because of, all right, so this guy actually had a real reason for that. I don't believe it. But you can also send a MIDI on message with a velocity of 0, right? So that's sort of an interesting way of doing that. Thank you. So let me go through and try this again. So let me open my input port. Then I'll have my output port.
It's like you're creating some fancy piece of 12-tone music.
Yeah, it's really, I don't have this mapped to any actual keys. All right, so cool. So now we've got the screen is sending MIDI messages out. So there's one last thing I'm going to do here before I eat all of your demo time.
Yeah, exactly.
And I'm going to make it so that I can take the MIDI input, just like we saw with FL Studio Groove. I want to take those input messages, and then I want to do something with them. In this case, I'm just going to take them, debug, print them out on the screen, and then pass them through to the analog 4. Okay? So let's do this last part. Each time that you get a MIDI message, you'll get an event raised. So if I go up here to my initialized MIDI, and if I say, actually, let me go over here. There we go. Say input port dot message received, right? And then I have an event handler for that. And I'm going to say MIDI. Well, let me create a status message. So string status, right? And I'm going to do, now what I'm going to do is I'm going to see what kind of messages I'm getting, because I could do different processing with that, but all I'm going to do is just use that to display stuff on the screen. So I'm going to say switch args.message.type. Okay, you saw, this is interesting because the MIDI message class itself, or this interface, I should say, you're able to get the type of the message, the raw data, et cetera. If you want to deal with this in the strongly typed way, you just cast it to the other class, or you can deal with the raw data. A lot of folks who have been doing MIDI programming for a long time have buckets of code already that can process MIDI messages, so we want to make sure you could still use that. All right, so let me do switch on the type, and I'm going to say it's a case MIDI message type dot, let's see, node on, and I can do some stuff, and then I can do node off, do that as well, and then some default, and all of these I'm just going to build the status message, so status equals, and in this case I'm just going to say it's args message type, and just spit out the toString of that. Okay. For the MIDI node off, I want to cast that to a MIDI node off message. So Do you like working with raw data, or do you like working with the...
No, I like working with types.
Yeah, I mean, so depending upon what kind of performance you're looking for, there's a very, very, very slight performance hit for casting the types. But you might find that that's actually no worse than what it would take for you to process the data yourself. So take a look at it. And if you're looking at really tight timing on this stuff, you'll want to evaluate the two options. Okay. So note on, say status equals note on, not on, note on. All right. And I want to be able to get the information from that, so I'm going to say var on message equals, let's see, args.message as MIDI note on. Okay. So that's going to cast that for me. I can say note on, and I can say note equals, and I'm going to add to that our on message.note. You see, because I cast it to the strongly typed one, I have some more information available to me. And I think I'll just leave that. I think I'll just leave it like that. All right, and then I'll do the same thing for the off message. You also get channel information and other things that you're going to need. So off, off, off. All right. One more. Off. Thank you. You guys are awesome. Thank you so much. All right.
It's like pair programming with 200 people.
Yeah. All right. Let's see if I have anything else here. All right. So now I've got my MIDI in, and then I've got the analog forward MIDI out. I haven't wired up the second half yet, but unless I mess something up, Colin, did I mess anything up? Okay. Let me see. Oh, I didn't add it to the list. All right. So I need to add that message. Actually, I knew I forgot something. I'm going to blame it on Colin. All right. And you just want me to debug in real time? No, my coding is bad enough without sitting here and watching me scratch my head over something.
So while you're at it, why don't you go ahead and pipe it through as well?
Yeah, why don't I do that? Yeah. All right, so let me, yes, I don't want to eat
this
all
is
your
my,
demo.
hey, Pete, move along.
So my MIDI debug, where's my MIDI debug? MIDI, or debug, where is it? Let me go back over here real quick. Control F, debug. MIDI debug. I don't know why it wasn't showing up. All right, let me try again. MIDI debug, and you're going to see there's something here that I can't do. I say MIDI debug.items.add status. All right. Now, the message received comes back on a different thread, so I need to say dispatcher.run async. And it's going to be core dispatcher priority.normal. And then I'm going to need to pass over what I'm going to do here. So MIDI debug.
So to be clear, this isn't something that's specific to the MIDI API.
No, this is...
I'm getting an event on a different thread than the UI thread, and I want to alter the UI, so I have to dispatch onto the UI thread.
Yeah, let me see why MIDI debug is giving me an error. No? Okay, strange. I'm actually, one thing that I didn't really point out here is this API requires update 1 of Windows. The update 1 that we're going to be releasing, I'm running a preview of that, so that might be why I'm getting some strange squigglies on stuff. Sorry, so that compiles. Now let me go ahead and pipe it through very quickly. So if I go back over here in this code, I can say output port dot send message, and it's just going to be args.message, because I'm just going to send the same message over that came in. And why is that there? Okay. All right, so MIDI in, MIDI out. All right, so I'm playing that. It worked. If I change the channel on this, I get that cool sound. If I change the channel, let's see. And we got to see different messages coming through. Now, if I start the sequencer here, I can send the control change messages and other stuff. Let me try to get this through on 1. There you go. That was an obvious one. All right, So all this stuff's going through. That sounds absolutely terrible. I'm not going to keep that going. So
I really don't care for your bleeps and bloops, man.
No, my bleeps and bloops are fun. So we're able to very quickly,
Yeah.
relatively quickly here, I think, take MIDI input, from a keyboard, be able to pass that through, process it on here in C#. This isn't native code. We're able to process it using C# code, and then be able to take that and then affect a MIDI output device. You saw there, we don't really have any lag, we don't really have any jitter issues or anything like that. So, pretty good there.
Yeah, not many lines of code either to do that.
Thank you.
Yeah, cool. So of course, one of the other things you have to think of when creating a music app is this idea of audio latency. But when we say audio latency, what are we really talking about here? Well, when I think about audio latency, especially on this kind of app, what I'm thinking is from the time I touch the screen and to the point I hear the sound, that delay or any potential delay I hear is the latency that happens in that audio path. And so what we want to do is we want to minimize that path that may happen in order to have less of a delay. Have you ever tried to play a piano with really an electronic piano on an on a Windows Store app? On another device that has really bad latency issues.
Yeah, I've even seen ones where they actually load the sound at the point where you press the keyboard. It's like not even buffered, so it's like bing.
Bing.
Right.
Yeah. So it's not a good experience to say the least. So you have to think about what contributes to audio latency, and there's some that are obvious, and there's some that are perhaps not so obvious. So from the point I touch the screen, the first thing that it happens is, of course, it goes through the OS input stack, and I have to think about what's the touch delay that's actually happening by the time I touch the screen to the point that I have code that runs. There's a certain amount of time that happens there. And then, of course, I have my code itself. How am I generating the APIs or generating the sounds? Am I doing like you said, where I'm loading up the sound when somebody clicks a button? Am I using a WinRT API? Am I using Xaudio 2? Am I using Wasapi? All of these kind of things, the higher API you get a better developer experience because there's things that are taken care of for you, but it also usually comes at the expense of more latency that's introduced to the audio path. So then my code, it goes down to an OS mixer, you have the drivers to think about, and we'll actually show some of the new features that'll help down there as well that you want to take advantage of as a developer.
Right. So we recognize that audio latency right now for Windows Store apps is not where it needs to be for every scenario.
Yeah,
right?
It's not ideal.
I mean, some apps like FL Studio Groove, where they've optimized it, you can get pretty decent performance out of that, but if you're a musician, you're still noticing that a few milliseconds of delay in there. So this is something that, as part of your team,
Yes.
we're working on in the future. We're working with a large number of partners to try to get information on what is appropriate audio latency, what is the best way for us
Yes, and
to...
we want good latency experience on any device you're using without the need for third-party drivers or any of that kind of thing. So there's a lot of work we're doing going forward to really improve the story here. Yeah, going forward. But we'll see some of the tips that we can go through to make a good experience today.
Yeah. So the first one is, before we even hit the audio stack, consider your other latency sources. So for example, loading the audio up when you hit the button. I hate a fart app that takes a couple seconds for you to hit that, and then you totally lose the moment at that point. So
you're experienced with those kind of apps then?
I have 2 kids, so I'm totally experienced with those kinds of apps. So that is one place where you can have latency. The other one is, let's say that you create the UI using a button, but you wait for the click event in order to have the audio start.
Yeah, and by default, the click event is actually going to wait. You press down, it's going to wait until you release, and then the click event by default. So you can change the click mode to on press in WinRT XAML, and then it'll actually fire the click event as soon as you touch the button.
Right, so we want to make sure that you're considering that right from the start. In XAML, for example, I use rectangles and I use the pointer press event as opposed to the pointer released event. You're also, in some of your examples, you've used buttons, but you've changed the click mode and stuff there. And if you really want the very best out of that, especially when you're sliding and dragging, you're probably going to want to use DirectX and some of the other technologies that we have.
So one of the other tips to think about is using event-driven Wasapi. Wasapi stands for Windows Audio Session API, and this is essentially on Windows. If you're not writing drivers, this is the API that allows you to get the lowest possible latency possible. It allows you to effectively, including with some of the new features we're introducing, tell the audio card exactly what it should be playing when. So you have direct control over those audio samples that are being sent down to the card. So Wasapi actually supports two models where you can be in pull mode, where you actually go and pull it to say, do you need more, do you need more? And you have to think about sleeping that thread, what do I do with that thread? You want event driven, where you tell Wasapi, call me back when you need more stuff, and I will give it to you. So here's an example. I'll show this working in my code, so I won't keep it up here for too long. But essentially, when I'm initializing this audio client, which is the Wasapi audio client, I tell it, I want this to be an event callback. Call me when you need more audio data. And then I tell it what Win32 event to actually fire. And then when that event gets triggered is Wasapi's way of telling my app code to say, hey, I need more audio data, give it to me. And currently I'm doing wait for single object to wait for it, but we'll see with MMCSS and stuff like that how you can make this even better when it comes to low latency.
So you mentioned Wasapi. So Wasapi is available on desktop?
Yes.
It's one of those APIs that's also available for WinRT apps.
Yep.
And also on phone?
Yes, also on phone. So using this, as we'll see in the upcoming demo, we'll see this same app and the same audio code using a universal app that's running on Windows Phone 8.1 and Windows 8.1.
Okay.
So one of the other things to think about, this is actually a new feature in Windows 8.1, which is this idea of raw processing mode, where when you're doing Wasapi, you can say, I want raw processing. Well, what is raw processing? Think about it this way. If you actually ever go into like your playback devices config and all that kind of stuff in Windows, there's all these enhancements that may be added, and every one of these enhancements that is added is potentially adding more latency to your audio path. This could be Dolby support, it could be this loudness equalization, bass boost, all that kind of stuff. And if you're trying to create a really low latency audio app, every one of those that exist on the user's machine can actually negatively impact the performance of your app. So when you actually set raw processing mode, what you're telling the audio driver is bypass all this. I want you to forget all those things exist and get me straight to the audio card. So it allows you to remove a lot of that extra processing that might exist in the audio pipeline.
I don't want to give up my bass boost, though.
Yeah, I know. You like bass. I'm not going to go into why. You were probably a fan of Ace of Base, weren't you?
I was, but that was a long time ago.
Okay. So one of the other tips is use MMCSS to prioritize your audio processing. So MMCSS, this was introduced back in Vista. It's known as the Multimedia Class Scheduler Service. And what it allows you to do is that thread that's processing audio, you can tell Windows, this is super high priority. In our case, we're going to mark it as Pro Audio. So what that allows you to do is tell the OS itself, this thread has higher priority than practically every other thread save for some OS threads that are running. So that way, it's not introducing issues on how much processing time, because if Wasapi needs more audio data and your thread isn't high enough priority to actually run, and you don't get that data to Wasapi in time, you're going to hear pops and glitches that happen in your audio app, and you want to avoid that. So using MMCSS, you can essentially make your thread priority high, which we'll see. So here, this is some more code on how to use MMCSS. The top line is this Pro Audio, where we're using Media Foundation to say this is a Pro Audio thing. And this is in combination with the event rendering thing, where the third line, the MF put waiting work item, you can see this mRender callback event. That is the event that we told Wasapi to actually fire when we need more audio code. So when you do this, you're telling MMCSS, when you actually get that event, spin up an ultra high priority thread, and then call me on this callback, this onRender callback, and do some code. So all this code, I should actually say this Beat Builder demo that we'll show is available on GitHub today, and I'll actually share out what that address is so you can get it. It's under the MIT license, so do whatever you wish with that sample code.
Cool. All right, so hardware offload. When I do graphics programming, I think offloading to the NVIDIA cards or whatever cards I'm using is a good idea. When you first brought this up to me, I was thinking, this makes zero sense to me. Why wouldn't you want to offload?
Right, and this is actually a newer feature as well, hardware offload in the stack. And what it supports, this is really meant for media playing apps, either if you're playing video or perhaps you're streaming music in your app. And what you're wanting to say is, I have a bunch of audio, and what I want you to do is I'm going to give the audio card like a second worth of audio data, and then I'm going to go to sleep. And so that way it's a battery saving thing where you save a lot of battery, you save a lot of resources. So you give it a bunch of stuff, you go to sleep and you wait. But it's like a second.
It's like a second. That's like, you know, 88,000 samples or whatever that you're dealing with.
Yeah, if you're two-channel and all that kind of stuff. Yeah.
So that's not what we want for low latency.
Right,
what we
exactly.
want for low latency is we want to give it 64 samples or something like that.
Right, we want it ultra low, and it's kind of, you know, in the opposite end of the spectrum of what you're really hitting for.
Okay. The other one here that's interesting is exclusive mode. How many people here have used Wasapi exclusive mode? I want you people to all pay attention. If you have more than one app on the screen at the same time, so I did some stuff a couple of weeks ago where I had FL Studio Groove running, and I also had Jordan's MorphWiz on the side, and I was playing both at the same time. But if you have Wasapi exclusive mode, you can't do stuff like that.
Right, when you're in Wasapi exclusive mode, you're essentially telling the audio driver, I'm the only one that can give you audio data. So I am the sole owner of this. So if a user is trying to use a different app that's trying to generate audio, it doesn't work. You can only hear the one from your system.
We have it there for those specific cases when, you know, it's not an app that's ever going to be multitasked. It's something that's internal to an organization, and they need to have the absolute lowest latency possible, and, you know, cooperation be damned, right?
Yeah, or a good example is like a digital audio workstation app, where it's a desktop app that you basically are almost guaranteeing by use that you're the only thing that's generating audio at that time.
Yeah. But we really ask that when you're working on Windows Store apps, you know, one of the great values of Windows is being able to have apps side by side, being able to have multiple streams of audio and stuff playing at the same time. So please, you know, think hard about Wasapi exclusive mode, and for apps that you put in the store, please don't use it.
Okay, so let's actually, if you can pop me over while we have some minutes, over to 8.
8? Yeah.
Yeah. So let's show this. I'm going to run this app. So here's an app we've created with all those tips, and I can play here, and I can create recordings and do loops. So I can loop, and then I can record other loops. All sorts of fun stuff. And you can see it's going around, but there's a couple things that are kind of awkward.
No?
Yeah, you like that?
Yeah, okay.
Yeah, no. But I do have some sounds especially for you. No drum pad is a complete drum pad without cowbell.
No, we always need more
So
cowbell.
you need cowbell. So you have to have some cowbell that's actually going. And then, of course, you know, in homage to our new CEO,
Fantastic.
we need the Satya.
Fantastic.
So, yeah. So let me actually record something. I'm just going to record some random stuff. Oh, yeah.
Oh, that's really cool.
Oh! Look at what you had me do, Pete. Oh, my goodness.
Was it my sample that did that?
Yes, I think so.
Yeah.
Also, I'll just blame it on you.
Yes, that works.
Okay.
Okay.
Now you'll notice if I actually go away, the audio goes away, which isn't really what I want. I actually want that audio to stick around. And if we actually bring up Proc Explorer, to the MMCSS thing, I'll show you. I can bring this up, and if we look at the threads, this top one is the thread that's generating the audio. Let me zoom in here, because that's a bit small. So that base priority, that priority is 8, and you'll see if we compare it to all the other threads that are here, that base priority of 8, it's the same priority as everything else, because we haven't hooked it up yet. So what I'm going to do, let's actually really quickly go hook all that up. Okay.
Now, this app that you did, it's C++, but you have a XAML front end? Is that
Yes, so it's C# XAML front end, and this is all C++ that's essentially exposing a WinRT object, and actually a series of WinRT objects that are called from the C# XAML.
Pretty cool.
And you'll see, if I come over here, it's using universal apps, and if I go up here to the C++ code, all the code is in the shared folder.
Great.
So it's using the same code on Windows Phone 8.1 and Windows 8.1. There's no if-defs in this code. It's the exact code on both platforms, which I think is pretty cool.
That is cool.
So what I'm going to do here, I already have this, where instead of using the default, I am actually going to use the Pro Audio one.
Okay.
Let's go ahead and run that again.
And so that's all you had to do to change the priority of this thread?
Yeah, exactly, because I already have it wired up into MMCSS and all that kind of stuff. So. So the audio still goes. We'll fix that in a minute. And yeah, that process is no longer around.
That was a very colorful Explorer there.
Yeah, exactly. Now, if we bring this up, you'll see that that audio thread that's generating the audio is base priority and dynamic priority of 24, and higher is better. So this has a higher priority than any other thread there, and effectively every thread except some ones that are necessary in the OS itself.
Okay. So for an audio app, that seems like a really good idea.
Yes, exactly. And it's super easy to do as well.
Okay. So what's the next thing you're going to do?
So we want to wire this up to the background audio. And what I can see here, so to support background audio on Windows, there's 3 things we need to do on Windows Store apps for Windows. We have to declare it in our manifest that it supports background audio. We have to support the system transport controls, which we'll see. And then here, when we're declaring the Wasapi stream, I'm going to tell that this is, I think it's background capable media, I think is the one. So let's actually run this now.
Okay. And what should happen is we should be able to get the audio running in the background even. Okay.
Okay, so it's looping. I have a comment still looping. And if I adjust the volume, you can see the transport controls come up, and I can go ahead and pause it and start playing it, all that kind of stuff from the transport controls.
Very cool. Very cool. Now, you had mentioned that this isn't just for Windows on
exactly.
touch machine. So where else can we run this?
So this is Windows Phone. You can run this on Windows Phone 8.1.
Okay.
And this is all also, since it runs on Windows Phone 8.1, it supports ARM and all that kind of stuff. Can we get this muted so I can switch it over to my phone?
Speakers for a second. You good? There we go.
Okay.
And then go ahead with the audio.
Now you should be able to turn it back up. So let me come over here and run that. I wish we had a projector up here to show you. But I have a simple grid here, and that's that same code, no if-defs, no nothing. It's all in a universal app, and it's all working here.
I think that's pretty cool.
Yeah.
What do you guys think? Good?
Yeah, very cool. So let's go ahead and switch back over. This code, like I mentioned, is all available on GitHub. It's under my personal account, github.com/Jolson88, Jolson88. I will tweet this as well, and it's the code that I'm using right here is the exact same code that's up there on GitHub.
Excellent. That's awesome.
Yeah.
Okay. So you got...
Yes, I got the clicker now. So remember, creative audio app dev right now is a great space to work in. Pete mentioned kind of the financial benefits of creating audio apps and how much more engaging they are. And frankly, to create one on Windows Store right now, there's not a lot of competition there. So it's a fantastic opportunity to get there and create all sorts of apps.
Right. And even though we said that, we're still working on latency and stuff for the next version of Windows, as you've seen from the demos that you've done and from the apps that are already there, you can get pretty decent latency numbers. And then when you add to that the MIDI capabilities, I think we've made it really easy for you to build pretty decent apps on this.
And the thing is, you can imagine using things like, since you're on Windows, you can use Connect for Windows, you can use sensors, and you can create all sorts of cool apps that people use.
Accelerometers, we do have USB connections, so like Connect for Windows, like you're saying, is really cool. Imagine creating a Windows Store app that you can, you can get your dubstep one by going like wah, 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 right? Something like that. There you go.
You would like that, yeah, for your bleeps
totally
and loops. Yeah. So, yeah, go ahead.
I said we're making it easier for you to build really cool apps on Windows for creative audio and eventually for video as well. We have entire teams working on that, but at the same time, we're committed to making it possible for you to develop these apps today using Windows 8.1 Update 1 and some of the new features that includes.
Absolutely. So if you have any feedback, go ahead and contact us. We're all ears. I like that. I see what you did there.
It took you until today to realize what I put in there.
Yeah, that's very clever. So we have our Twitter information here. I have my email address. I think Pete's trying to say he doesn't have an email address or something like that.
Oh, I didn't put mine up, but it's pete.brown@microsoft.com.
Yeah, so feel free to contact us. We would love to hear feedback. Like Pete says here, we're definitely we're here kind of for the long haul with our media platform and our media creation and editing team, and we want to make this a success going forward. So if there are features that you need or features you would really like to see, we would absolutely love to hear that.
Yeah. And same thing on the MIDI API. Since we are releasing that as a preview, get your feedback to us early. Go and create cool apps with that. Even if the Wasapi stuff is a bit daunting, you can create some really cool controller apps and sequencers and other things using just the MIDI API.
Yeah, absolutely. So show us what you're doing. We would love to see it. Go out and build apps, mess around. Your imagination's the limit here, and we want to see all those great ideas that all of you have and that you want to try to do with all this functionality.
Yeah. And then finally, unless you thought this was a sucky session, please fill out your evals. Right? So.
Yeah, it wouldn't be a build conference without saying fill out your eval. So thanks everybody for coming. You're a great crowd. Thanks a bunch. If there are any questions, feel free to migrate to the microphones and we'll go ahead and try to answer them. I know, exactly. Yes, go ahead, Jim.
Whether it's working or not. Quick question regarding managed versus unmanaged decision between C# and C++, and also is .NET Native impacting their decision as well?
So actually, that's a good question.
What was it,
about .NET Native?
.NET Native.
Yeah,
I'm not
are
sure.
you familiar with .NET Native?
Yeah, I'm not sure how that fits in on all this right now, but this is, we're getting pretty decent results from doing just even managed code, but the reality is that most of the people out there who are already building audio apps are doing it in C++ code to begin with, so we want to make sure it absolutely works for that, and then just the fact that we're making available via WinRT, and also some of the future work that we're working on making that available, WinRT will make it so you can use managed or native code. Right, or other stuff.
Yeah, cool.
So
okay.
WinRT stuff can be used from JavaScript and everything else.
All
right?
sorts of stuff. Yeah. Okay, this side.
Is there currently good documentation on all this stuff?
So we're going to put out horrible documentation on all of this.
So we're actually working with a partner of ours that everything I talked about, especially with SAPI, we're going to have a white paper that we're publishing that goes in, it's like 37 pages that goes into all the gory details of this. And then of course in the future we're going to be producing the documentation up on MSDN for the MIDI API, all that kind of stuff, and all these code samples will be available as well.
Right. And if you can't find the documentation, just send us an email and we'll point it to you, or tweet us and we'll point it to you.
Yeah.
Point it out to you. Yes,
Yes,
you can go live.
it's a
with
go
any of this
live
stuff.
license on the MIDI API. Yep.
And traditionally, UI thread and input comes at 60 FPS. Is there any tips or tricks to make it happen in the fastest way?
So that's talking about the UI thread for input on that, at least, and I'm not a DirectX expert, but when I talk to the input team about how their input latency works and touch latency works and stuff like that, they weren't concerned about that. They have, we have latency numbers for touch devices that must report, and I forget the hertz that they report, but they must produce the initial touchdown in less than 25 milliseconds, I think, which is actually reasonably competitive with other platforms right now.
But that's an area that we're definitely
yeah.
looking at. As we mentioned, of all the areas that latency can come from, that is one of the potential
Yeah.
areas. So we are doing the investigations, how to streamline that and how to really minimize what happens there.
So for example, we talk to them and explain the importance of tap. Like right now that the touch processing for input optimizes for swipe, for panning and stuff like that. So it does hold on to it for just a little bit before you get that tap information. And we've been explaining that, hey, for audio scenarios, the tap for being able to do these types of apps is just as important. So no promises on what they will produce, but we have made the team aware of that.
Yep. Okay, over here.
Do you have any short-term plans for higher-level constructs like, say, reading MIDI files or
So that's
sound
a
fonts?
fantastic question. Currently, we don't have any short-term plans, but those are the things that we're definitely looking at as the next steps of what we need to do in this space. And we're trying to look at all the different possible things we need to do around new MIDI features, new new audio API features, all that kind of stuff. So we're looking into all of that and what we can do.
Yeah, so the
Put
partners that
sound
we've
fonts
spoken
on
to.
that list.
I'm sorry.
What was that?
Put sound fonts on that list.
Sound files?
Sound fonts.
Sound fonts?
Oh, sound fonts. That's a really good idea. I'll capture that to take back to the team.
Okay. Other questions or? No? Great.
Great.
Thank you, everybody.
Thanks, everybody.